Okay, this is Year 11 topic mock we did at our school. The idea being that you've got to get all the questions. If you can get all the questions right, you should be getting at least a grade C in the exam. I'm going to go through these quite quickly because on most of them you should just need a bit of reminding on. First one is index numbers. When you've got to multiply the index numbers like that, you simply add them. So you do 3 add 7, should give you p to the power 10. If you want to know why, p to the power 3, imagine that as being p times p times p. P to the power 7 is p times p times p, and so on. So then you're left with p times p times p times p times p times p, and that will give you p to the power 10. If you're dividing, you subtract. So that will leave you with p to the power 1 or just p. The next one looks a bit tricky, but it's not really. You do the top line first, so that will give you x to the power 7, because you add the 4 and the 3. Underneath, it will be x to the power 6. So then you divide those two, so that means subtract. So it'll be x to the power 1, which is just x. On the next one, solving the equation. Solving an equation means finding the value of x. So 4 times what? Take away 7 is 33. Some people can just look at that and they can recognise it's 10, but it's good practice to go through the workings for the harder ones. You need to get x on its own. That is the idea. So we're going to get rid of this negative 7 or a minus 7. How do you get rid of a negative 7 or a minus 7? You add 7 because that takes it to 0. But of course you've got to add it to both sides. So that leaves you with 4x equals 40. 4x means 4 times x. How do you want to do a times by 4? You divide by 4. So it leaves you with x equals 10. The next one is very similar, this one. You need to get rid of that negative 2 or minus 2. So you add 2 to both sides, which I've done here. And that leaves you with 6x equals 6. So 6 times what is 6? Well, it's 1. Or you could just divide both sides by 6. So x equals 6 divided by 6. Well, how many 6 is going to 6? It's 1. Next one, solving an equation again, but there's unknowns on both sides. My technique for this is to get rid of the smallest thing first, be it letter or number. And in this case, it's a negative 3. So what I've done is added 3 to both sides, which leaves you with what I've got here. The next step is to get all the y's on one side, so get rid of the smallest number of y's, which is the 4y, so taking 4y off both sides. That leaves me with 4x equals 8. How do you want to do it? Times by 4, you divide by 4, so it leaves you with y equals 2. Nice little tip for these is you can check if you've got it right. If y is 2, 8 2s are 16, take away 3 gives you 13, and 4 2s are 8, add 5 also gives you 13, so you know you've got it correct. The next one, get rid of the smallest thing. The smallest thing is negative 10, so I'm adding 10 to both sides. There you go. So adding 10 to both sides, so you need to do a negative 6 add 10, which gives you a positive 4, so that's why you've got that. Take the 2x off, which is what I've done here, and that leaves you with 2x equals 4. So you need to divide both sides by 2, so that leaves you with x equals 2. Again, if you substitute it back in, you will see it'll work. The next one, solve the inequality. This is basically solving an equation. You need to find out the value of x. The only difference is you need to take out the inequality sign and put an equal sign in. So what I've done here, look, I've replaced that with an equal sign there. Got rid of the 3 from both sides, so 5x is 25. How do you want to do it? Times by 5, you divide by 5, so x equals 5. But your final answer, you must put the inequality sign back in to get the full, usually 2 marks for that one. At the bottom there's another one. It'll be a bit trickier, this one. Again, I've replaced the inequality with an equal sign. I want to get rid of that 10 because it's bugging me. So I'm take away 10 from both sides. And you're left with 10x equals 5. A lot of students put the answer down as 2 for this, but be really careful. You've got to divide both sides by 10 to get x on its own. So 5 divided by 10, I've written it there as a fraction. You need to recognise that that is a half, and you can even simplify that. So x, inequality sign, a half, or 0.5 would also be fine for that one. Next one up the top, it's drawing inequalities. Here we go. Draw the inequality. X is greater than minus 8 but less than or equal to minus 1. That second point there means equal to. So we draw 2 circles either end, connect them up, and the reason that one's coloured in is because it can be equal to minus 1. That's why it's coloured in. It cannot be equal to negative 8 because it's more than negative 8. Next one, excuse the things I've scribbled out. There's a few bit of photocopying, never mind. Draw the inequality, so there we go again. So it's bigger than minus 3, but less than or equal to minus 7. So that's why the minus 7 one is coloured in, because it can be equal to it. Next one, find the midpoint of the line. Well, here's my line here. So what you 2 ways of doing is you can just look at it and work it out. I mean, just looking at this one, I suggest it's probably there. But in the exam, they might just give you the coordinates. So what I encourage my students to do is this. We write down the coordinates of each end of the line. So that point there is 1, 4, which I've got there. That point there is 4 minus 2, which is what I've got there. And you're going to find them basically the mean average. So what's in between them. So you're going to add them up and you're going to half it. So there's my adding up for it. So 1 add 4 is 5. 4 add negative 2 is 2, and then you half it. So it's 2.5, 1, or divide by 2 there. And that's what I've circled there. The next one, just by looking at it, you can tell the midpoint is probably 0.3. But again, it's important to go through the process because this could come up without the graph. There's my coordinates, added them together. I've got to half it. What's half a 0? Well, 0 was half a 6, 3. And 0.3 is there. And you can see that's a very sensible answer. If you get the answer of 4.1, which is there, don't put it down and try again because that's clearly wrong. Next one, show without using a calculator. This is a really vital skill. You can do long multiplication. I use this way. I think it's the simplest way of doing it, and you see my workings there. 61 times 63. This is a question you should be able to do. I'm not even going to talk you through it. Next one, again, no calculator, show your workings. 8 times 57p. So what I've done is 8 times 57p. There you go. 456p. So obviously that's going to be £8.56. Circumference of circles. Well, circumference is pi times the diameter. You need to know that for the exam. You won't be told it in it. The diameter is the line that goes across the middle of the circle but through the centre, so it's 32 centimetres. So pi times 32, it says round answer to 1 decimal place, so it's 100.5 centimetres, and I always put brackets 1 dp if it asks for 1 decimal place. The one underneath that is very similar. You need to use the formula again. Circumference is pi times the diameter. Always write it down. I've not done it for this one. The diameter of this one is 2, because that's the radius it's given you. The diameter is all the way across, and that's just the radius because it only goes halfway across. So it's pi times 2, 6.3 centimetres, 1 decimal place. Please make sure you put in units, centimetres. Next one, I think it's area of circles. There you go. Area is pi r squared. You need to know that. R is the radius, so that's from the middle to the outside. So this one's nice. It's pi times 4. Forget 4 because 2 squared, 2 times 2 is 4. There you go, there's your answer, 1 decimal place, give units, centimetres squared. Next one's a little bit trickier, pi times radius squared. Well, the radius here is only 1 because the radius is from the middle to the outside, so it's pi times 1 squared. 1 times 1 is 1, so it's 3.1 centimetres squared, and I've put brackets 1 dp because I've rounded it. Next one, calculate the area of this compound shape. This always comes up. Let me zoom in so you can see what I've done. I've split the shape there, look. So I'm going to work out the area of the bottom bit. Well, it's 3 by 3, which is 9. And the top bit, and I've circled it there, I've put, look, this is what you need to do in the exam. You need to draw arrows, show exactly what you're doing, make it dead obvious. It's a triangle. So the formula for the area of a triangle is base times the height, then you half it. So here we go, base is 3, the height is 2, because the whole height is 5, that bit's 3, so that must be 2. So 3 2s are 6, divided by 2 is 3, so 9 add 3 gives you 12 centimetres squared for that one. Next one, again, exactly the same thing. I've split it up, look. So I've worked out the area of the rectangle I've got, which is 6 by 4, which is 24. And then you're going to work out the area of this triangle here. Well, you know, the base is, you could argue it's turned up, but the base is that line there. So it's 6 times, and the vertical height there is 4. So it's 6 times 4, then you half it, like you always do with a triangle. 6 4s are 24, half it is 12. So the final answer is 36, because it's your 24, add your 12, gives you 36. Next one, calculate the volume of this cuboid. Let me zoom out a little bit so you can just see the question. There we go. Volume is what goes inside it. So it's like how many little square blocks could you fit in it. The way I do it, and the way I encourage my students to do it, is to work out the area of the cross section. This is the cross section I'm shading in, and that's the cross section because it's the same all the way through. Funny enough, with a cuboid, the cross section you could go from either direction, but we're going from this one. So the area of that bit is 1 times 8, which is 8 centimetres squared because it's area. Then you times that by the depth, which is 32 centimetres cubed. You could just do 1 times 8 times 4 all in a row. The only danger with that is if they start giving you other lengths. So for example, if they tell you that's 8 as well, which you already know, if you don't understand what you're doing, you might do 1 times 8 times 8 times 4. So you might get it wrong, so be a bit careful. Next one, again, area of the cross section, which is 17 times 3, because it's 3 high, it gives you 51. 51 times 5, because it's 5 deep, is 251 centimetres cubed. Don't forget volume is cubed. The next one is surface area. This is the area on the surface. I can never understand how this is the most easy question people get wrong all the time. You should, at this level, be able to work out area without even thinking. So the surface area is just work out all the areas and add them up. So what I've done here, look, I've tried to make it really simple. The top and bottom are the same. That's the top and that's the bottom you can't see. So that is 6 along there and it's 4 back there. So 6 4s are 24, and I've doubled it because obviously there's a top and a bottom. Front and back, well that's the front obviously, which is 6 by 2, so that's 12, but that's obviously a back, so doubled it, that's 24. 2 sides, 4 across and 2 up, so 4 by 2 is 8, double it because there's 2 sides is 16, add them up and you get 88 centimetres squared. I mean, you could get a more complicated one, I suppose, with triangles on it and things, but just go through the same process, show your workings like I'm doing. You can pick up marks for it. You don't have to get everything absolutely spot on. If it's a 3-mark question, you can get 2 marks. That's pretty good. The one underneath that, surface area, look, I'm going to leave it there. Same thing again. You can follow my workings through, and it's 132 centimetres squared. If you want to look at that one in a bit more detail, just press pause. Question 13. This is Pythagoras. You've got to recognise it's Pythagoras to use it. It's a triangle. You're not given any information on any of the angles. You're not asked to find an angle, so you've got to assume it's Pythagoras. And Pythagoras is a squared and b squared is c squared. C is always the long side. And in this case, it's an easy Pythagoras question because you're asked to find the long side. So let's have a look from the top. Look. A squared, well A I've labelled as 4, B I've labelled as 12, and C is what we're trying to find. So A is 4, so 4 squared add 12 squared is C squared. 4 squared is 16, 12 squared is 144, that's still C squared. 16 add 144 is 160, so C squared is 160, square root it, and I get 12.6 centimetres to 1 decimal place, because it says to 1 decimal place. That's how you do it. The one underneath is a little bit trickier, it's not rocket science to be frank though. Again, label it up. C is always alongside, A and B don't really matter. A is 4, so I've labelled that. B we don't know, we're trying to find out, so I've left it at B. C is 20 squared. So 4 squared is 16, 20 squared is 400. So you've got 16 add something is 400. And the way you can work out what that something is just do 400 take away 16, which is 394. You can't see that very clearly because I left it on the windowsill and it's gone a bit wet. 394, so that's what b squared is. Square root it and you get 19.6 centimetres, and that is brackets 1 decimal place I've put in there. Look, you know, the answer to this has got to be less than 20 because 20 is the long side. So if you get anything more than 20 because you've added by mistake, which is fine, you know you've gone wrong. So if you make that mistake, go back and correct it and do the takeaway version of it. The next question is actually a B grade topic. It's trigonometry. I think it's quite a nice B grade topic, so that's why I always have a go at it. You need to know this. There's some old hags carry a huge tub of apples, is how I remember it. Sokatoa is another one. And the other one you could do it is something on holiday comes after having tons of alcohol. However you remember it, you make sure you remember it. Right, you need to recognise you've got to use it. So it's a little bit like the Pythagoras ones, only there's an angle involved. Either they've given you the angle or you might be trying to find out the angle. First of all, label your sides up. So hypotenuse is always alongside, so I've done that. Opposite is the one that's opposite the angle, so it's there, and the adjacent is the other one. We're trying to, what 2 sides are you interested in? Well, that one because I know it, and that one because I'm trying to find it. So it's the hypotenuse and the adjacent. So which one of these has got hypotenuse and adjacent in? It is cos. So we're going to use cos for this. So what you do is just cos the angle. So cos 22 equals, now the adjacent was x, that's why that's on top. And the hypotenuse was 20, that's why that's on the bottom. And you can see that comes from there, adjacent on top, hypotenuse on the bottom. We want to basically get x on its own. So what I've done is multiply both sides by x is being divided by 20, so I've multiplied both sides by 20 to undo it. Like solving an equation, you've got to do the same thing to both sides. So 20 times cos 22 equals 18.5 centimetres, and I've rounded that to 1 decimal place. The one underneath is a very similar question. Label it up. Again, so there's your opposite. Hypotenuse is the long one, and adjacent is the other one. You're interested, well, you know you're adjacent, and you're interested in your opposite. So which one is that one got in? Well, it's tan, because tan is opposite over adjacent. So tan the angle equals, now which one's the opposite? It's x, so that goes on top, and adjacent, which is 7, goes on the bottom. You basically work out what x is, so you want to get x on its own, so you divide, it's been divided by 7, so to undo that you multiply both sides by 7, so 7 times tan 70 equals 19.2 centimetres. Again, that's 1 decimal place. These next ones I'm just going to show you. I'm not really going to talk through them. There you go, you've got to use your calculator for this. Don't round it or anything stupid. Just do what it says. 2.1 squared is that. Square root of 3 is that. Work that out on your calculator, you'll get that. If you're clever enough, you can, or you know how to use your calculator well enough, you can just do it all in one go on your calculator. I would encourage you just to set it out like this. I know it takes time and it's a bit of a pain, but just don't make a mistake and you'll get the marks for it. If you use a calculator, sometimes the settings are on something funny or the BODMAS rule kicks in, so just be careful, alright? This one here, square root of 7, 0.4 squared, do the division, there you go. That easy. Pause that if you want to check the answer. These next ones are always done wrongly, so we're going to spend a little bit more time on them. Calculate x, so there's a missing angle x here. There's a lot of information you need to get down to get these marks. First of all, you need to notice that this is an isosceles triangle because those two are the same length. And in an isosceles triangle, you know, or you should do, that these two are the same length. Well, I just said that, but these two are the same size angle. So what you want to do is there's 180 degrees in a triangle. So 180, take away 110 gives you 70 degrees. And I've said here, isosceles triangle, these are equal. So you do 70, divide it by 2, basically cut it in half, gives you 35 degrees. So you know that that one and that one are 35 degrees. You're not interested in that one, you only want to know that one really. Because there's 180 degrees on a straight line, so 180, take away 35, gives you 145 degrees. And you need to put all that information down. The one underneath is bizarrely a little bit easier, but again, it's an isosceles triangle, those two are the same. So it's 180 degrees in a triangle, so 180, take away 108 is 72, half that, then you'll get that angle is 36 and that angle is also 36. But you need to be saying, you need to write, it's an isosceles triangle, these angles are equal. You need to write down there's 180 degrees in a triangle, otherwise you will not get the mark. Next one, moving on. 4 chickens cost £10, work out the cost of 5 chickens. Well, work out the cost of 1 chicken is the easiest thing. So you do £10 divided by 4, gives you £2.50 per chicken, times it by 5, there you go. Next one, a little bit trickier. 2 kilograms of pears cost £2.40, work out the cost of 700 grams of pears. Well, first of all, you need to know that 2 kilograms is 2,000 grams, and kilo means 1,000. So what I've done is found the cost of 100 grams. So £2.40 divided by 20, because 2,000 divided by 20 is 100, so you need to divide the price by the same, gives you 12p per 100 grams. So if 100 grams is 12p, times it by 7 to get the price of 700 grams, and you should get 84p. The next one is currency conversion. These ones are relatively simple. £1 equals €1.60. If you had 320 euros, how many pounds would you have? You either got to divide it or times it. People always get confused by it. The way I try and encourage students to do it is this. Is your answer going to be bigger or less than 320? Well, it's going to be less, look, because there you go, you can see that when it goes to pounds is less. So you're going to divide it and it should get £200. The next one, again, you divide it by 1.5 and you get us 380. Right, these are nice and easy, but people always get wrong. Find the nth term of the sequence, and then I put what is the 100th term. Well, it's going up in sevens each time, so it's 7n, right? So that's your first term, that's your second term, that's your third term. So 7 times 1 is 7, take away 6 gives you 1. And that take away 6, look, you know that, because 7 times 1 is 7. How do you get from 7 to 1? You take away 6. 7 twos are 14. How do you get from 14 to 8? You take away 6. And so on. And it will work for all the terms. So the 100th term is 7 times 100, 700, take away 6, 694. Next one, it's going up in 3s each time, so it's 3n. 3 times 1 is 3. How do you get from 3 to 7? Well, you add 4. Check this one. 3 2s is 6. How do you get from 6 to 10? You add 4. So 3n add 4. Find the 100th term. Well, it's 304. Because 3 times 100 is 300. Add your 4. Next one, speed, distance, and time. You need to know this speed, distance, time triangle. Otherwise, you just can't do them. How far does it travel? So it's asking you, first of all, it's asking you to work out the distance, because it's how far you travel. This is how I do it. If you cover up the D, you're left with speed next to time. So that means speed times time. So distance equals speed times time. So it's 90 times 2.5. It's 2.5 hours. So it gives you 225 miles. Again, the one underneath, I'm a bit annoyed I put both distance ones in, but there you go. You cover up your D for distance. Distance is speed times time. So it's 20 times 4.5 gives you 90 miles. If you wanted to work out the speed, what you do is cover up the speed. So speed is distance divided by time, because it's over there, look. If you wanted to work out the time, you do time is distance divided by speed. So there you go. Right, the second half, this is the next lot, basically. Multiplying out a single bracket, you know, you see what I've done there. 3 times x is 3x, 3 2s are 6. And there's a plus sign, so put that in the middle. A lot of people put 3x add 5 because they add and they forget to multiply. You must multiply. This one, if it's got letters in as well, it's a bit tricky, but just do this. Just do the numbers first. So 2 2s are 4. X times y is xy. You put the negative sign in next if you want. Then 2 times 6 is 12. Then there's an x we've got to add. And that's all you do. Next one is double brackets. I've done the smiley face method or the foil method. I've taught you through it. So the first bit is x times x is x squared. 2 times 3 gives you the 6. 2 times x gives you the 2x. And 3 times x gives you the 3x. You need to simplify this. So x squared always goes at the beginning. Then do your x's. Well, you've got a positive 2 there and a positive 3. So that's positive 5x. Because basically 2 add 3 is 5. Then you put your 6 at the end. Next one's a little bit trickier. X minus 2 squared. Well, squared means times by itself. So there you go, look, times it by itself. X minus 2 times x minus 2. Do your smiley face or your foil or whatever you want to call it. And here we go. So x times x is x squared. Negative 2 times negative 2 is, well, 2 2s are 4, but a negative times a negative is a positive. So that's why that's positive. Negative 2 times x is negative 2x, and x times negative 2 is negative 2x. Again, group your x squared goes first, group your like terms. So you've got negative 2, take away 2, or minus 2, take away 2, or minus 2, minus 2. It'll give you minus 4. Because you start your number line minus 2, then you take away 2 more. Then you add 4, that goes in. Next one, factorize. That means put into brackets. So what's common in 2a and in 4? We'll do the numbers first. What's common in 2 and 4? Well, 2 is, so you put 2 on the outside. Any letters common? Nope, so you don't bother. So you draw your brackets on. 2 times what gives you 2a? What, 2 times a? 2 times what gives you 4? What, 2 2s are 4? There you go, done. If you want to multiply that out, you can check your answer. Look, 2 times a is 2a. 2 times 2 is 4, and you put that plus sign in the middle, and there you go, you're back to what you started. Next one, you got no numbers common, but you got a d common. So you take the d out of the brackets, that's your common factor, that's why it's called factorizing. Then you draw your brackets. D times what is df? Well, d times f. D times what is 5d? Well, it's 5, and you could do the same thing, multiply that again. This next one, I'm not quite sure why I put them on, a bit easy, but there we go. Your like terms, so there's your 3x and there's your 5x, that's 8x. There's 2y and there's 7y, that gives you the 9y, there you go. This next one's a bit trickier. 7q, take away 3q, because that take away or minus sign belongs to that 3q. So 7 take 3 gives you 4q, then you're left with 4p, positive 4p, look, add 4p gives you the 8p. So that's how you do those. Moving on. These next ones are fairly quick. Now you're unlikely to get a question exactly like this in the exam, but these are just rules you need to know. Normally they jumble it up and try and confuse you. You need to be able to recognise that that is 70 degrees. Most people can do that, but what most people can't do is tell me that it's a Z angle, and a posh name for a Z angle is an alternate angle, and you must give me the alternate, the word alternate, and there you go, there's your Z, I'll draw it on for you. The way I remember it, because Z and F angles, zebras live in Africa. they tend to. Or an F angle, well, an F, I always think FC, football club. So that's a C, that's corresponding angle, and that's the one underneath. Look, I'll draw the F on for you. It's actually an upside down and backwards F, this one, but there you go. No, tell her no, it's not upside down at all. There you go, it's just a backwards one. Goes along there and along there. So that is the same as that, and that is a corresponding angle. You need to know these things because they'll be part of solving problems in your exam. Increase £30 by 20%. Yeah, you can if you wanted. Just find out 10%, then which is obviously 3, then double it, so that'll be 6. So it's 36 is the answer. The way I try and get students to do it, because I think a lot of them can do that, is to recognise how to use the multiplier. So to increase, that as a decimal is 0.2. So if you're increasing, you do 1 and you add on the 0.2, and that's where you get your 1.2 from. And that 1.2 goes there. Same for the next one. Increase by 25%, well, that's 0.25. So 1 add 0. Okay, question 7. It's similar stuff, but it's decreased this time. 30% as a decimal is 0.3. So because we're decreasing, it's 1 take away 0.3, which is 0.7. So you do 70 times 0.7, and that gives you £49 for that one. Next one, again, decreasing. So 47% as a decimal is 0.47. So it's 1 take away 0.47, which is 0.53. So you do £30 or 30 times 0.53, and in this case you get 15.9. Because it's money, don't forget it's 15.90, because it's always got to be the 2 decimal places. Next one. Here we go. This comes out quite a lot these days, these ones. So 22 times 33 is 726. So use that to work out this. Well, what you've got to recognise is the decimal point has gone from there to there, and it's gone from there to there. So both of those have got a factor of 10 smaller. So this is going to go this way twice. There you go, and there you go. The other way of doing it is just to look at it. Well, 2 3s are roughly 6. Isn't it? It's going to be probably a little bit higher because it's 2.2, 3.3. So the answer is going to be around 6 or 7-ish somewhere. So how do you make this nearly 7? Well, put the decimal point in between the 7 and the 2, so 7.26. Next one, 36 times 521 is 18,756. Okay, so on this one, the decimal point has gone that way 1 space. On this one, it's gone this way 2 spaces. So on this one, it will go 3 spaces. So 18.756. There you go. Right, getting there now. Estimating. What you want to do, basically round them to. I mean, you can argue it should be the nearest significant one significant figure, but it doesn't always work out like that. Just round them to the very near nice number, and these will always work out, so they get them to work. 19 is nearly 20, 41 is nearly 40. There you go, 20 times 40 is 800, 2 4s are 8, put your 2 noughts on. This one here, well, that's going to be 5, that's going to be 10, so 5 10s are 50. And I'm looking at that thinking, well, hang on, 50 divided by 25 is going to be quite easy. So I'll make that 25, and it gives you the answer of 2. Don't use a calculator. Don't round that to 9.8 and try and work it out. Estimate means quickly do it in your head. And it's a skill, being able to round these numbers so you can do it quickly. Right, next one. Write the coordinates for the graph y equals 3x, add 1. So this is going to be a linear graph. So these are x values on the top, y values on the bottom. You're trying to find out the y values. So 3x, add 1. So 3 2s are 6, add 1, 7. 3 1s are 3, add 1, 4. 3 noughts are 0, add 1, 1. At this stage, you can notice it's going down in 3s. So you just take off 3 each time. There you go, done. Next one is a little bit tricky because an x squared in it. So I'll take a bit more time on this one. Always start from this end, by the way, because it's always positive, so it makes it a little bit easier for you. On this one, it says for the values of x from -2 to 2, and I've actually drawn it on nicely for you because I'm kind. In the exam, it might not do that, so you might have to draw this little scaffold yourself and just write x is -2 all the way up to 2. Right, x squared, take away 2. 2 squared is 4, take away, because that's x, that's your x value. 2 squared is 4, take away 2 is 2. 1 squared, so it's your x value, is 1. 1 take away 2 is -1. 0 squared, well, 0 times 0 is 0. Take away 2 is -2. This is where people go wrong. -1 squared. -1 squared is -1 times -1. And a negative times a negative, you've got to know, is a positive. So it's 1, take away 2, so it goes back to -1. And the last one is minus 2 times minus 2, because it's squared, which is positive 4. Take off 2 gives you 2. That's going to be a curved line. You know it's a curved line because it is a squared in it there. This next one is ridiculously easy. 18 is product of its prime factors. That means you've got to write down a multiplication sum made of prime numbers that will always make the top one. And you can do this in loads of different ways. Don't add, it's always multiplying. I've done 3 by 6, and 3 is prime, look, and 6 is 2 3s. People always put 3 times 3 for 6, which it isn't, because they add and they make a stupid mistake. Don't be that person who makes a stupid mistake. And the answer is 2 times 3 times 3. I think it's just common courtesy to put them in order. If you want to give it as an index number, you can, because 3 times 3 is obviously 3 squared. You can do that as 2 times 9, and you will get the same answer. You can't do 1 times 8, well, you can do 1 times 18, but it's wrong, because 1 is not a prime number. A prime number only has 2 factors. So you've got to know your prime numbers and stop at them. Next one, 80. Well, I've done 8 and 10, look, and I'm not going to explain it. There you go, you can see what I've done. Next one, put this number into standard form. I don't like that light on there. Standard form is basically you have something, a number between 1 and 10, times 10 to the power whatever. So what you do for this one, look, how's that going to be between 1 and 10? Well, it's going to be 3.2. Zoom in a little bit. There we go. So the decimal point is there. So it's 3.2 times 10 to the 1, 2, 3. So that's why it's 3.2 times 10 to the power 3. The next one, 7.07, because it's got to be between 1 and 10, times 10 to the power 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where the decimal point ends up. So that's why it's that. Right, that's got the pages. Do a calculation with numbers in standard form. There you go. A little bit tricky, but not too bad. Just do your numbers first. So 3 times 2 is 6. Then 10 to the power 4 times 10 to the power 3. If you think all the way back to the start of this paper, if you're still awake now, look, when you're multiplying index numbers, you just add them, don't you? So same thing here. You do the 4 add the 3 gives you the 7. So it's 6 times 10 to the 7. That's fine, because that is between 1 and 10. This next one, however, 7 2s are 14. 7 add minus 2 is 5. But that's not in standard form, because 14 is not between 1 and 10. So you have to move the decimal place 1 space more that way. That changes it from that to 1.4 times 10 to the 6. Next one, write down the value of 25 to the power of a half. To the power of a half is square rooting, so square root of 25 is 5. The next one, 4 to the power minus 3. This is actually quite a nasty one. This. What I want you to do first is ignore the negative. So 4 to the power 3. That's 4 times 4 times 4. 4 4s are 16 times 4 is 64. That negative means you've got to write the reciprocal of it, and I don't like going down that line with it. So basically the trick is, if it's 4 to the minus 3 or whatever, work out what 4 to the 3 is, then just simply put 1 over 64. Okay, so for example, I could have said, what is 5 to the negative 2? Well, there you have a bit of chance to work it out, but if you do 5 squared is 25, but because there's a negative there, it's 1 over 25. That's all you're doing there. Next one, back to solving an equation. Again, solving an equation means work out the value of x. These aren't really that much harder, but the only people don't like them because they've got, over here it looks like it's done as a fraction, and they think, oh, algebra fraction must be difficult, I'll leave it. No, it isn't. You need to get the x on its own. This side is all being divided by 4. How do you undo a divide by 4? Well, you multiply by 4. There we go, look. So because you multiply this side by 4, the divide by 4 goes, so you don't have to multiply these by 4 again. So 5 4s are 20, and just go through the normal process now. Take off the 2 from both sides, 3x is 18, divide both sides by 3. You get 6. Again, substitute that back in if you want over here. So 3 6s are 18, add 2 is 20, divided by 4 is 5, and there you go. Next one, it's being divided by 7, so multiply by 7 to get rid of it. So that gives you 5x add 5 is 35, get rid of that 5, 5x is 30, and then you want to get x on its own, it's being times by 5. What's the opposite of times by 5? It's divide by 5. So divide both sides by 5. 30 divided by 5 gives you 6. Rearrange the formula to make x the subject. Okay, so you want to get x on its own, basically. This first one's dead easy. A bit like solving the equations, this. You want to get x on its own. What's happening to x? Ask yourself. Well, it's been times by 3. Okay, what's the opposite of times by 3? Divide by 3. There you go. So x equals y divided by 3, because you've divided both sides by 3. Next one, rearrange the formulas to make x a subject. A little bit tricky because it's in brackets, but there's no skills that you don't know if you've made it this far. 3 times x, multiply the bracket out. 3 times x is 3x, 3 times 2 is 6, equals y. Let's get rid of this 6, because we're trying to get x on its own, so take away 6 from both sides. So 3x equals y, take away 6, there you go. What's happening to x now? Well, it's been times by 3. Well, what's the opposite of times by 3? Divide by 3. So divide both sides by 3. That leaves x on its own, and y take away 6, divided by 3. There you go. Right, last few, thank goodness. There you go. So plot these on the thing. I'm going to go through it really quickly. The lowest value, you can't see the grid, I know, but the lowest value is 9. You've got to trust me there. That's your lower quartile, that's your median, that's your upper quartile, and that's your highest value. So I'm going to write that down. That's your lowest, that's your lower quartile, that's your median, that's your upper quartile there, and that's your highest value. Please don't get that wrong in the exam because it's easy. Calculate the interquartile range. Okay, well, you know, you'll usually be asked to do it from here. The interquartile range is from here to here, and I'm going to draw a line. It's this distance from there to there. But the way we work it out is just by doing the upper quartile, take away the lower quartile. And actually, I don't need to bother reading them off here because I've got them written here. So that's why it's the upper quartile, take away the lower quartile. Upper quartile is 45, lower quartile is 24. Boom, there you go. That gap there is 21. Next one, I'm not going to go through this one, same thing. Lowest value, lower quartile, median, upper quartile, highest value. Interquartile range is 28, take away 16. Done, it's 12. Always show your workings for it, please. The length of a table is 90 centimetres to the nearest centimetre. So, what's the smallest it can be, the lower bound? Well, what's the smallest number when you round to the nearest centimetre will give you 90? 89.5, because it's 0.5, you round up. If it's 89.49, you'd round down. So that's the lowest it could possibly be, the length of this table. This one's, it's not difficult, harder, but to be honest with you, but there we go. The highest it could be is up to 90.5. We don't tend to write on 90.5, it's up to 90.5. Don't write 90.499999999 because it will go on forever, and technically that actually is 90.5, but there we go. So write up to 90.5. If you don't like doing it this way, if it's the nearest centimetre to the nearest 1 centimetre, what you want to do then is find out half of 1, which is obviously a half, take half off and add a half on, and that's all I've done there. Same thing here, to the nearest 1 metre, well that's half a metre, take half off, add half on, that's where you get your answers from. And the very last couple here, thank goodness for that, go home, is rounding to significant figures. So here we go, 3 significant figures. So that means 3 main numbers, so 3, 5, now it's a 7, 9 there, but you can only use one more number, that's 79, or round up to an 8, look, because that will make that 8, so that's 3980. 1 significant figure, is it nearer to 3,000 or 4,000? It's nearer to 4,000. Last one down here, 3 significant figures, well it's 7, 5, 9. Now, will that 9 be rounded up? Nope, because it's only a 1 there, so 75900. And is it nearer to 70,000 or 80,000? It is nearer to 80,000. If you can do all of those questions and do them confidently, you should be getting at least a grade C in your GCSE maths exam. If you cannot do those questions and you're not sure of them, then do something about it. Go and see your teacher, be it me or someone else or someone from another school, and make sure you can do them. Don't go into your Year 11 GCSE maths exam, if you're doing a higher paper, without knowing how to do them. If you do, you're setting yourself up for a fall, because those questions, most of them will definitely be in there. So make sure you know them, please.